Hey there, in this video we're going to cover section 2.6, transformations. So this will be what happens to a graph when you perform a transformation. So we're going to start with the graph of f of x equals x squared. And we would know that this, if you do a table of values, if you don't know what the graph of this looks like, we can do, there's some standard ones, -1, -2, 0, 1, and 2. So when you plug it in, right, -2 squared gives us +4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So we can plot those points in graph, but we would know that this is a parabola. What we're going to explore is what happens to it when we graph these other functions. What happens to x squared when we add 1? What happens to x squared when we subtract 3? And when we multiply it by 3 or multiply it by 1/4. And so we're going to take a look. So I've already graphed our y equals x squared here, f of x equals x squared, our nice parabola. Based on the t values, the t chart, we have 0, 0. When x is 1, you have 1 as well. When x is 2, you have 4. So this is a point 2, 4, and over here the mirror image is the point -2, 4. So this is the graph of y equals x squared. So what happens when we graph, I'm going to graph it in blue over here, what happens when I graph f of x equals x squared plus 1? So if I have, let's do a t-table for this, x and x squared plus 1, so if we do the same values, -2, -1, 0, 1, and 2, notice that I'm going to get x squared, -2 squared is 4 plus 1, that will be 5. So this one is going to go up by 1, it's going to go to 5. -1 squared is +1, plus 1 is 2. So this point here, -1, 1, is going to move up to 2. 0 squared is 0 plus 1 is 1. So this 0 is going to move up over here to 1. So we're starting to get this parabola is moving essentially up by 1. I put in 1 squared plus 1 is 2. 2 squared is 4 plus 1 is 5. So we're starting to get these points that are just essentially moving up by 1 unit. So when we plot those, what do we get? So we end up with this blue line inside our red one. So notice that we have the red one is our original parent graph, y equals x squared, and the blue one is our new one, y equals x squared plus 1. So we call this a vertical shift. So this graph, doing the plus 1 made it so that we had a vertical shift of 1 units up. And so this is the graph of y equals x squared plus 1. So what do you think is going to happen when we graph f of x equals x squared minus 3? So what is that minus 3 going to do to the graph? So since plus 1 made a vertical shift up, minus 3 will make sense. There will be a vertical shift down. And so we get a graph that looks like this one. So again, the red one is our parent graph, y equals x squared. Oops. Y equals x squared is the red one. And then the blue one is y equals x squared plus 1. And now that we have this vertical shift down, this green one is y equals x squared minus 3. So notice that now our y-intercept is over here at 0, minus 3. So all the points of y equals x squared have been moved down by 3 units. So whenever you have f of x equals x squared plus c, c is a vertical shift. And it's c units up if c is positive, right, greater than 0, and c units down if c happens to be a negative number. So like in this case, x squared minus 3, that moved everything down by 3 units. So now what happens when we when we multiply by say 3x squared and 1/4 x squared? So what happens to our parent graph? So we'll do the same thing. So I'm going to copy that one, our parent graph, down over here. This is our y equals x squared. And so now I want to graph. This is y equals x squared. And we want to graph y equals 3x squared. So what will the 3 do? So let's take a look at the t-table. So if I have x and 3x squared, so we'll try the same values, -2, -1, 0, 1, and 2, and see what's happening. So when x is -2, again, -2 squared is 4, times 3, I'm going to get 12. -1 squared is +1, times 3, I get 3. 0, I'm just going to get 0, so the vertex is not going to change. And for 1, 1 squared is 1, times 3 is 3, and 2 squared is 4, times 3 is 12. So what is happening to this graph now? So we end up getting a graph that is stretched out like this one. So the graph here on the inside is our y equals 3x squared. So notice that when x is, I'm going to focus on the ones that we can see here. So -1, 0, and 1. So when x was -1, notice that we went all the way to 3 instead of being at -1, 1, like we were in the parent graph, right? -1, 1 here in the parent graph. So it's stretching it. So it's the same x value, but the y value is stretched out. And so we get the same thing here. At 1, we go to 3. And so it's not a vertical shift because our vertex is staying the same. So notice that the vertex didn't change here. It's 0, 0. And also if we go to 2, right, this is going to be, in the blue graph, we don't even see it here. It's going to be way over here at 12, right? This is going to be 2, 12. So it's not a vertical shift because 1, our vertex is not changing. The vertex is staying the same. Unlike the graph here where the vertex moved up. And so that's a vertical shift. In this case, our vertex is not moving, it's staying the same, but the y values are getting stretched out. Notice how the graph is almost as if you're pulling the red graph up and, well, not up, not as a vertical shift, but as a, you're like just stretching it, holding down the vertex and then just pulling it, so it makes it stretch vertically. So that's what the 3 is doing. So what do you think the 1/4 is going to do? Right, the 1/4 x squared. So instead of stretching it vertically, we might guess that, yeah, it's gonna make it so that it is, it flattens out. So it shrinks the graph vertically. And sort of like it flattens it up. So it's going to open it up. So let's see what that will look like. So if we look at the t-table for y equals 1/4 x, 1/4 x squared, notice that now we're going to have my x and 1/4 x squared. So if I pick my same values, at -2, right, -2 squared is 4. 1/4 of that will be 1. -1 squared is +1, so 1/4 of that will be 1/4. And so there's the shrinking. 0 is 0. So notice that the vertex is not changing. At 1, we're going to have 1/4, and at 2, 2 squared is 4, times 1/4, we get that 1 again. And this is how I know that I have a parabola, because we start mirroring points. So what does this graph look like? So when we graph it, this is what it looks like. We have that green graph. So this graph is our y equals 1/4 x squared. So this shrinks the graph vertically by a factor of 4. So notice that by shrinking it means it's pushing it downward. So again, imagine that the red graph or parent graph is sort of like a rope or a string, and you're stepping on it with your foot right at the vertex. And so if you pull it, that gives you the blue graph. So you're stretching it. And then as you instead, if you were to kind of like let it go, instead of pulling it up, you're just kind of loosening the rope, then it's going to widen it. And so that's what happens. But that's what's happening in here. So when your coefficient is a fraction, it's widening the graph, like the green one here. When your coefficient from the x squared is a whole number, then you are making that graph narrower. So that's another way you can think of it. So a large coefficient makes the graph very narrow. A small coefficient, so a fraction coefficient, makes the graph very wide, taking it from the parent graph. So the parent graph is the y equals x squared. So this is what happens vertically. So when you have a plus or a minus, it's a vertical shift. So you're either moving the graph up by that number, including moving the vertex, or you're moving it down. And when you have a coefficient where you're multiplying it, then that is either you're stretching the graph vertically or you're shrinking the graph vertically. So stretching the graph vertically means it's kind of like you're narrowing it, making it narrow. And shrinking the graph vertically means you're actually widening the graph. And in my next video, we're going to do what happens when you do things horizontally. So we're going to play around with graphing f of x equals x cubed and seeing what happens when we do things inside the parentheses. So these create horizontal shifts.